Have you ever felt the ground shake or seen a picture of a towering volcano spewing lava? These are some of the most powerful and terrifying forces on Earth, and it's no wonder that they've captured our imaginations for centuries. But with all the myths and folklore surrounding them, it's easy to get confused about what's fact and what's fiction. Today, we're going to bust some of the biggest misconceptions about earthquakes and volcanoes. We'll separate the scientific truth from the Hollywood special effects. So, grab a seat and get ready to have your mind shaken. Let's start with a classic one. A lot of movies and TV shows depict earthquakes causing massive, deep chasms to open up in the ground, swallowing cars and buildings whole. It's a great visual, but it's completely wrong. In reality, earthquakes are caused by the sudden release of energy along a fault line, which is a fracture in the Earth's crust. The plates on either side of the fault slide past each other, or one moves up or down relative to the other. The movement is almost always horizontal or vertical, not a gaping crack. While some cracks can form in the soil, they're usually small and shallow, and they're a secondary effect, not the main event. The real danger of an earthquake isn't a giant hole in the ground. It's the shaking itself, which can cause buildings to collapse, triggering landslides and tsunamis. This is another fan favorite. The idea that California, specifically Los Angeles and San Francisco, will one day just drop into the Pacific Ocean. Again, a dramatic and terrifying thought, but scientifically impossible. The San Andreas Fault is what's known as a strike-slip fault. The Pacific Plate and the North American Plate are grinding horizontally past each other. The Pacific Plate is moving northwest, and the North American Plate is moving southeast. They're not pulling apart from each other. They're just sliding past each other. The most likely long-term scenario is that in several million years, Los Angeles and San Francisco will be adjacent to each other. The plates are moving at a rate of about 2 inches per year, which is roughly the same speed your fingernails grow. So don't pack your bags just yet. You might have heard people say that volcanic eruptions are more frequent during a certain time of year, or that they're somehow linked to the seasons. This is simply not true. Volcanic eruptions are driven by geological forces deep within the Earth. The pressure of magma, the movement of tectonic plates, and the release of gases are the primary factors. These forces are not influenced by the weather, the temperature of the air, or the Earth's position in its orbit. The only potential external influence is the weight of glaciers. When glaciers melt, the reduced pressure can sometimes trigger eruptions in certain volcanic regions, but this is a very slow and long-term process, not a seasonal one. When we think of a volcano, we usually picture a tall, perfectly conical mountain, like Mount Fuji or Mount Vesuvius. But this is just one type of volcano, called a stratovolcano. Volcanoes come in all shapes and sizes. Shield volcanoes, like those in Hawaii, are much flatter and wider because they're built up from very fluid, runny lava. Cinder cones are small, steep-sided volcanoes, and a caldera is a large, cauldron-like depression formed after a powerful eruption causes the ground to collapse. So, the next time you hear the word volcano, remember that it could be a towering peak or a massive hidden depression. It might seem like we're hearing about more earthquakes now than ever before. With 24/7 news cycles and social media, it's easy to get the impression that the ground is shaking more often. But the data tells a different story. The number of major earthquakes, magnitude 7.0 and above, has remained relatively consistent over the last 100 years. What has changed is our ability to detect them. We now have a global network of seismographs that can detect even the smallest tremors, which were previously undetectable. So, while we may hear about more earthquakes, it's not because they're happening more frequently. It's because our technology has improved, and our ability to communicate information has dramatically increased. You've seen it in the movies. Scientists race against the clock to find a way to stop a volcano from erupting. But this is purely science fiction. A volcanic eruption is an unstoppable force of nature. It's driven by the immense pressure of magma building up in a chamber deep underground. The forces at play are on a scale that we, as humans, simply cannot control. The best we can do is monitor volcanoes and try to predict when they might erupt. By using seismographs, gas sensors, and GPS to detect ground deformation, we can get an early warning and evacuate people in time, saving countless lives. We can't stop the eruption, but we can prepare for it. When we think of a volcanic eruption, we often picture a violent, explosive event with a huge plume of ash and a fast-moving lava flow. But not all eruptions are the same. The type of eruption depends on the type of magma. If the magma is thin and runny, low viscosity, and has a low gas content, the eruption will be effusive, meaning it will produce a slow-moving lava flow. This is what we see in places like Hawaii. If the magma is thick and sticky, high viscosity, and has a high gas content, the eruption will be explosive, like the eruption of Mount St. Helens in 1980. So, while a lava flow might be a concern, the more dangerous eruptions are often the ones with a lot of gas and ash, which can produce fast-moving pyroclastic flows and can cause widespread ashfall. The Pacific Ring of Fire is a term we've all heard. It's a great name that describes the active seismic and volcanic region that surrounds the Pacific Ocean. But the name can be a bit misleading. The Ring of Fire isn't a solid ring of volcanoes. It's a long, complex series of tectonic plate boundaries where the Pacific Plate is subducting or diving beneath other plates. This subduction process creates magma, which rises to the surface and forms volcanoes. The Ring of Fire is home to around 75% of the world's volcanoes, but it's not a continuous chain. It's a chain of chains, and there are huge gaps in between the volcanic arcs. The idea of the big one is a powerful and terrifying one. It's the idea that a single massive earthquake will strike and cause unprecedented devastation. While a major earthquake is a real possibility in many parts of the world, there's no single cataclysmic event waiting to happen. It's more accurate to think of it as a series of events. The Earth's crust is constantly under stress, and that stress is released in a series of earthquakes, big and small. A very large earthquake will happen at some point, but it won't be a single final event. The Earth will continue to move and adjust. The most important thing is not to live in fear of the big one, but to be prepared for it. Having an emergency kit, knowing what to do during an earthquake, and having a family plan are the best ways to protect yourself. So there you have it. The ground won't swallow you whole. California won't fall into the ocean, and not all volcanoes are created equal. The reality of earthquakes and volcanoes is far more fascinating and complex than the myths and misconceptions we've been told. By understanding the science behind these incredible forces, we can not only appreciate their power, but also learn how to live safely alongside them.